Gases. So the process of changing from a liquid to a gas below the boiling point is called evaporation. Okay, so evaporation is the process of going from a liquid to a gas below the boiling point. Now, particles in liquids vibrate vigorously and they move past each other, but they are in contact with each other. So in a liquid, you'll have different particles that would still be in contact with each other, but they can move around. Okay, so these all move past each other. So they're moving in all different directions, and they're basically in contact but moving around. Um, some of these particles will have enough energy to escape from the surface of the liquid, like our example here. We have some of these that are basically breaking free and flying off into the air. Well, those are ones that had enough energy near the surface of the water or the liquid, and they were able to escape into the atmosphere. Now, liquids vaporize quickly at the boiling point, okay? So some terms here to really think about. You have vaporization. Okay, vaporization is this whole process of going from a liquid to a gas, however it happens. Doesn't matter how it happens, we call it vaporization. It goes from a liquid to being a vapor or being a gas. Now there's two different types. You have evaporation, which does happen below the boiling point. Okay, so here you just have enough energy in some of these particles that they are able to escape the surface of the liquid and fly off into the air. At boiling, there's enough energy that you can actually have bubbles form. So you actually have enough energy that the liquid will vaporize not only at the surface, but all the way through the liquid. Like if you have water boiling, the bubbles that form are actually water vapor bubbles. The gas that's in those bubbles is water vapor, and then it basically rises to the surface and escapes to the atmosphere. Now it gets a little complicated, but we have something called vapor pressure. Vapor pressure is the pressure that the vapor itself would push back down on the surface of the liquid. Okay, so below the boiling point, the vapor pressure is less than the atmospheric pressure. Okay, so the vapor pressure is less than the atmospheric pressure when you're below the boiling point. So evaporation occurs here. Once the vapor pressure equals the atmospheric pressure, then bubbles can form and rise, and that's when things actually boil. So boiling doesn't really always happen at a specific temperature. Like water does boil at 100 degrees Celsius if you're at sea level. But if you're high on top of a mountain, the water may boil at 90 degrees Celsius or 85 degrees Celsius because the atmospheric pressure is lower. So you can actually change the boiling point by changing the atmospheric pressure on the liquid. But anyway, in gases, particles are separated by large distances. So unlike liquids, the particles in a gas are separated by large distances. And so they're not in contact with each other. And these particles basically travel in a straight line at a high speed until they bump into something. They could bump into other atoms, other molecules, the walls of the container, etc. So this basically means gases have no definite shape and no definite volume. They will take the shape and the volume of their container. So whatever they are in, whatever the gas is in, like say a propane tank, the propane basically expands to fill up the entire tank, so it takes the volume and the shape of the tank that it's in.